Welcome back to the bench. What we have today for a teardown is a electric car heater. This is a portable unit, battery operated, that you would use to warm up and defrost your car maybe in the morning before going out to work. It has a clock function on it, has different settings, heat, even has a light, you can use it as a torch. Obviously battery backup for the clock, so hopefully we should see some kind of RTC in there. This whole thing weighs probably about a good couple of kilos, maybe a bit more. It's quite old, it's over 10 years old this. I've had this for a while. I used to use it for warming the car up, so I didn't have to scrape in the cold winters. But yeah, now it just doesn't work, so I'm guessing that the battery's died in it, and judging by the weight, it's a lead acid battery in here. Definitely not going to be lipos or nickel metal hydride or anything like that, just to the sheer weight of it. So without further ado, let's get some screws open and cruise out and get this thing open. Have a look inside. So looks like 6 screws. Oh, yep, and we're in like Flynn. Okay, so there's our little clock battery. It's its own little holder with 2 wires. So let's just get that out. It's just a standard CR2032. So I guess the holder's molded directly into the case. Yeah. Or is it actually a separate holder? If it is, it would be good to salvage that. If possible. Okay, looks like it was soldered in after it was fitted, so let's cut those off. And that's heat staked on there. It actually looks like it might be a separate little holder that's on its own little daughter board. Let's get these heat stakes out. Oh yes, that's nice. So that is actually a proper coin cell holder, so we can salvage that. Use it in future projects. So I believe they call that upcycling. Okay, so it does use lead acid batteries, but it looks like, yeah, they're 6-volt batteries. So it's using 2 batteries. It's the input socket. Might come in useful for some things. Strange connection though. Okay, so it's using 2 6-volt batteries in series with each other, and they're taped together. Let's get these out. See if there's any life in them. Meter out. I'll lay it flat so that you can see it. Let's put it on PC. Okay. Battery number 1. Oh, that's reading millivolts. So yeah, that's gone the way of the dodos. Maybe we can try and get some charge back into it, try and recharge it, but it's a sealed battery, so you can't change any electrolyte or anything like that. There's a number in the top. Is that a model number? 11079. Yeah. And battery number 2. That has 216 millivolts. So yeah, both of them are as dead as a dodo. So it could be that if we can get some charge back into them, we'll have to have a look. Okay, so getting into the guts of it, there's our switch panel. So that's a double switch and a single switch, and a DC input jack. So that's just hot snotted in there. They must have put it in and it must have been loose because the other ones are clipped in. So yeah, we can potentially salvage these. Okay, so that's the wire going off to our heater, and our heater's just here. Let's see if we can get this out. That's screwed down. So let's clip some wires, get this out of the way totally. That's one screw out. Okay, so that's our heating element. Oh, nice. Okay, the whole fan assembly just comes out. Hopefully that's going to be on a JST or something. And that we can just snip it off. Yeah, it looks like it goes directly to the switches. Yeah, so we'll just have to, oh no, that goes to the board. So where's that going to? Oh yeah, that is going to a JST. So that's actually quite a nice squirrel fan. I mean, it's quite chunky. How wide is that? Okay, so that's what, 28 millimeters. So what's that in? Inch and a quarter, nearly, in width and in thickness. So yeah. Seems to spin freely, not too much dust in there, so yeah, that could be useful in a later project, something that needs cooling. Okay, let's take a look at our heating element. And this is just a resistive element. From memory, this was it's actually made up a series of like 3 separate elements. This was a 150 watt heater, so on full charge it only ran for about 10 minutes, but usually that's all it needed just to raise your car up a degree or two, just to melt the ice off the windscreen. Can we push these out, or is it just firmly in there? Yeah, they might come out. So we can take a look at the actual elements. Okay, and this is some kind of thermal cutout as well. You can see that. It's just a nice little package there. Presumably it's for over temp. So let's see. Yeah, it's got some markings on there, but yeah, it's a little bit hard to see. There's no temperature rating by the looks of it. It's just a manufacturer's mark, safety marks. Okay, pop that off. Get these other wires out of the way. So yeah. So these are actually bonded together. So yeah, this is literally the metal, is literally the element. So yeah, it's quite a neat little construction, and as I said, it's 150 watts. Maybe we could use this as a resistive load for something. If it takes 150 watts. Interesting. Okay, so now we have this switch panel, so we can get this out of the way. So I'm thinking this is just going to be pretty much on the other side just a blob chip. The RTC is probably going to be contained within the main clock chip, which is a shame. I was hoping to find a separate RTC chip in here which I could reuse, but it doesn't look like it. But there are a couple of good looking relays. Okay, let's get the main circuit board out. There we go. Okay, so yeah, this is just the control board. What's under there? It's just a connector. That wire soldered directly on. So we just got some transistors and diodes, looks like a Zener. Connectors, LEDs. So all the clock must be on here. Yeah, there's a separate board there. Yeah, so the battery went directly to this board. I'm serious about keeping this in place. 2, 4, 6, 8, 10 screws in this little board. Oops. Okay, so here is our clock module, and it's actually, oh, we could have taken the whole unit just out. I thought that was part of the casing, but it's not. It's actually just the whole separate clock module that's been inserted into there. That's quite neat. So we can get all the screws out. I mean, they're a bit tight. So in theory, we could use this clock module for, on this screw, for something else. Oh, that's some kind of, oh, that's a piece of plastic. I just shredded it. Oh, and there is actually a little chip in there. Maybe that's some kind of ROM. Oh, it was actually designed by the looks of it for the battery to actually go directly onto this PCB. And instead they've just soldered some wires on. Looks like it was designed to take a surface mount CR2032 holder. Okay, and we have a little chip on here. Let's see if we can see what this is. Let's bring in some magnifying glass. It's an LM393. Yeah, so that's going to be some kind of comparator. So yeah, that's just going to be for switching the load, whatever it's got to turn on. It'll send a signal through down to these relays. Yeah, if you look at the traces from the connector, they go straight down to our relays are, and then you've got the extra solder on the tracks for the current handling. Yeah, PTC, so yeah, that's our sensor that was on side for the over temp. So it's quite a neat little design. And the clock chip is just sitting here. And all this is just the timer, and you've got your 3 buttons. There's your zebra strip, your LCD. Nothing fancy. So yeah, and put that back together and maybe power it up. Might be able to use it as a clock module for something else, a little timer for a little project. There's your ground. A little croc crystal. Yeah. I think that. So that is a teardown. Let's just take a look at these two relays. Not familiar with the brand, but they are 12 volts coil DC, and they'll switch 15 amps at 14 volts DC, or 15 amps at 125 volts AC. That's not bad. They can be salvaged. They're just going to be single pole relays, probably. But yeah, any markings on the transistors? There is, but I can't see them. Oh, is that a 78 aliphi? Let's get my glasses on. No, 7136A is the number on that transistor. SO8050, and that's the same. So yeah, just some jelly bean transistors. They're probably just driving the coils for the relays. Okay, so that was a teardown of a electric car heater. So if you enjoyed watching this video, give me a thumbs up, and don't forget to hit that subscribe button and ring the bell for notifications of when I upload new videos. So it's goodbye from me, and I will catch you next time.